In this lecture, we are going to study about some general properties of superconductors. This is Unit 5, Lecture 8. What is superconductivity and who discovered it? The phenomenon of superconductivity was first observed by H.K. Onus in 1911 when measuring the electrical conductivity of metals at a low temperature. Superconductivity is a phenomenon in which electrical resistance of materials suddenly disappears below a certain temperature. The materials that exhibit superconductivity and which are in the superconducting state are called as superconductors. The temperature at which the transition from normal state to superconducting state takes place on cooling in the absence of magnetic field is called as critical temperature or transition temperature. The transition is reversible. When the temperature of the material is increased above Tc, it passes into the normal state. So here you can see what is the transition temperature. For normal metal, there is no transition. Its behavior is as the temperature decreases, resistivity also decreases. Now for a superconductor at a particular temperature, the resistivity suddenly becomes equal to 0. This point is known as the transition temperature. For mercury, it is about 4.15 K. Among pure metals, niobium has highest transition temperature and tungsten the lowest. Ferromagnetic and antiferromagnetic materials are not superconductors. Some properties of superconducting materials are they have zero electrical resistance, persistent current, critical temperature, critical magnetic field, and perfect diamagnetism, which is also called as Meissner effect. What is persistent current? Once a current is started in a closed loop of superconducting material, it will continue to flow as long as the loop is held below the critical temperature. So you would see that in this loop current is flowing and a magnetic field is generated. Such a steady current which flows without diminishing in strength is called persistent current. Persistent current gives rise to magnetic field. So whenever there is a current, you know that it gives rise to a magnetic field. What about critical magnetic field? Superconductivity disappears if the temperature of the specimen is raised above Tc or a strong magnetic field is applied. The minimum magnetic field which is necessary to regain the normal resistivity is called the critical magnetic field Hc. The value of Hc varies with temperature. At any temperature T which is less than Tc, the material remains superconducting until a corresponding critical magnetic field is applied. The critical magnetic field required to destroy the superconducting state decreases with increasing temperature. The dependence of critical field on temperature is given by the equation Hc at a temperature T is equal to Hc at 0 Kelvin into 1 minus T by Tc the whole square, where Hc at 0 is a critical field at 0 Kelvin. So this is what we have seen in this lecture about what are superconductors and what are some general properties of superconducting materials.